Well, hello. I think we're recording this time. I sure hope so. This is my second try, and this is going to be an all-nighter because it's 4:17 in the morning. I'm going to sleep late tomorrow. Anyway, this is chapter 10, and usually chapter 10 I don't use the PowerPoint because we usually do it in the CAD lab because everything we do is in on AutoCAD. And so, and actually, instead of going in, taking pictures of the book again, putting it in a PowerPoint, I decided just to check out a couple things on the web, and I found two really good PDFs of pattern developments, or what we call, development drawings. And I will give you the links to these, but I'm going to go through them kind of quickly, just because I know you're not going to want to read all of this, okay? So anyway, these are principles of pattern developments, okay? And really, you're going to hear it called different things. You hear a pattern development or a stretch out development, but basically it is a flat pattern that is going to be folded, bent, rolled into different shapes, and there's different ways to do it. And here's the biggest, easiest way to look at it. And actually, it says up here, the packaging industry is probably the one that uses the most of it, other than sheet metal. Sheet metal, there's a lot of sheet metal things like a file cabinet or your duct work in your basement. And I'm probably going to forget part of the things because it is like 4:19 this morning. So if I'm a little spacey here, that's why. Okay, but anyway, this is a typical looking development. And you see here, this is a box, and I know you're all familiar with boxes, and you probably even bought a flat box and bent it all into shape. But anyway, this is what we would call a pattern development, and it is used a lot in the sheet metal industry. Here is a real simple example of that. It's a spatula, and that was at one point a flat piece, and it got bent into a different shape, a three-dimensional shape. So here's a very simple thing. If this was sheet metal, here is the bottom of the box, and this is the bottom, and these are the short sides and the long sides. These are called fold lines. And when you're drawing those, you do draw the fold lines so that everybody knows where to bend them. But this is a box with a cover, and then this is a box with a drawer. And you've probably seen this happen too. In fact, I'm going to show you some real life ones in a couple videos. You're going to have a lot of videos to watch today. All right, so this is the flat pattern, and just another little box there. And then there are some things that start out flat too, that besides bending, that will get put into other shapes. But we don't really cover that here, but I'll just show you these because they're just here. And this one is either die stamping or spinning sheet metal. Have no clue how that's done. I don't know a lot about some really different forms of manufacturing, but I do know about bending. So, but anyway, this is calculating volume. You don't have to do that. But what we are going to do is look at different types of patterns that we're going to make. And this is a cube, but it's also called a prism. And this is got 6 sides to it, and these are plane surfaces. Now, we talked about plane surfaces a couple chapters ago. This is a plane surface, this is a plane surface, but this cylinder actually is a curved surface, but we still can do a development drawing for a curved surface because it can be flat and then rolled into shape. Okay, so we're going to look at the different types of developments, and we're going to start with the very first and simplest one, and this is called parallel line development. And it's called that because you'll notice that most of these lines are parallel. They're all parallel, and you'll see in some ways it might not always end up as a cube, but it will still be parallel line development. And then then we have another system called radial line development. And this is what they would look like. We'll get into that a little bit more. And you see in this one here where you can just bend these at 90 degrees, or actually you don't have to be 90 degrees, but at different angles. But they will all the sides are in some way parallel to another side. Where this is not true, these sides are going up at an angle. These are actually oblique surfaces. And if I were to bend this, what they call tetrahedron, down flat, this is what it will look like. This middle triangle is the bottom, and then these are the three sides. And when you bent those up, this is what it would look like. This is an octahedron, and it is also done by radial line development. This one too, and this one too, and they're pretty complicated, but I think they're pretty cool. And then there's another type called triangulation, and that's basically kind of like radial line development, but I don't know exactly. You can read this. It says such as double curved surfaces, and they can't exactly be done with radial line development. It's kind of a combination of triangles, as you see here. And then, of course, when we're doing things like sheet metal, even in cardboard and different things, you'll see different types of seams, and we'll talk about that in a little bit. But and then there are what we call transition pieces. Don't really understand their figures, how they do these figures, but this is another parallel line development. But you'll notice that this side here is curved, but it still is being developed because when we lay it out flat, the lines are still parallel. So it's not parallel to every line. But you'll see when you bend it, it would be parallel. So I wish I don't know if there's an animation coming up, but there are some animations coming up. But this actually, if you see side A, here's side A, here's B, and it's got that angle to it. And here's C, which is just a square. And then D is exactly like B. And then actually 1, 2, 3, 4 sides. So 1, 2, 3, 4 sides. And then here's E, which is that angled surface. Now it's going to be bent and folded into this side. And so it's not going to be, it is going to be bent at 90 degrees here and here. And it's kind of, unless you actually get to make this and bend it, which we would be doing if we were in class, sometimes it's kind of hard to see. But this is called truncated. That means that we've sliced it at an angle. And then here is a surface of a cone, and this is actually radial line development. And so in parallel line development, you always have something that we call prism, and this is a prism, or a cylinder, and a cylinder is actually rolled in parallel line development. And then in radial line development, it could either have straight sides or curved sides, and that would also be rolled. So this is radial line development, and this is what we call transition pieces. And that means it actually goes from one shape to another shape. So this is a small circle, and it's going to a bigger circle. This is a square that's going to round. This is a square going to round. And you'll see some real life stuff like this when I show you my basement, which I'm going to do in one of these videos. I've already made the videos, but okay. So good reading. I really like this PDF. I don't know where it came from. Might have said it at the beginning. Okay, but anyway, let's look at parallel line developments. Okay. And the first thing you do is probably start out with the orthographic drawings. And so here is your front view of this prism that we're making. Here's the top view. We don't need the side view. And then we're going to make out what we call a stretch outline. The stretch outline is just adding up all of the lines. So from 1 to 2, 2 to 3, 3 to 4, and back to 1, we're going to measure that, what that would be. So for instance, if this was 2 inches plus an inch plus another 2 inches plus another inch, our stretch out line would be 6 inches, okay? So here we go, and here you could just, there's different methods to do it. I wish I could show you on AutoCAD, but I guarantee I'm not going to have time tonight, because by the time I'm done with this, the birds are going to be singing. So anyway, from 1 to 2 is marked here, from 2 to 3 is marked here, 3 to 4 is marked here, and then go back to 1. You always go back to 1. And the height is just going to be projected over, because it's the same height all the way over. And so you have your completed pattern development right here. Now, if we were going to put this together, we would have to have some sort of seam. And so when we're doing this in our classroom, if we had the chance to do it this year, we would have been putting these little tabs on here, and then we would print it out. We would bend these lines and then bend these tabs, and we'd use these tabs to actually to glue or tape the prism together. And by this time, if it had been a normal year, there would be all kinds of shapes cut out and put in the inbox to be graded. Now this is called a truncated prism, and this is pretty much done the same. Here we got the top view, and we're going to calculate just the area or the perimeter around here. And here again, if this was 2 and this was 1, we'd have a total of 6 inches. Okay, so we're going to lay out that stretch out line. Here it goes from 1 to 2, 2 to 3, 3 to 4, 4 to 1. And then we're going to calculate the heights, okay? And so we've got A, B, and C, D. So we're going to transfer A over here and B over here. And then we're going to transfer C to here and D to here. And I'm going to skip this part right now, but then we're also, because we're always going back to that first point, so we're going to transfer A to here. So what you're going to end up with is, when you connect it, you're going to have the shape of the truncated part. Now, we always put on our bottom, unless this was hollow, we have to put on our bottom, and the bottom is actually just the top view. And we try to put it in an area that would save the most amount of material. So, you know, if you put it over here and put it over here, you're going to actually use more material. So we're going to put it all on this side. And then you would just take that auxiliary view and connect it over here. And then when you would have the complete flat pattern of this truncated cylinder. They didn't actually show it with tabs, but in our case, we would put it with tabs. Now, here is a cylinder that is rolled into a cylinder, but we lay it out as a flat pattern. It's very, very simple. This time, this is just the circumference of the cylinder. So if we had to, we would actually put tabs on it, maybe a top and a bottom, and that would be in the CAD lab right now. All right, so cylinders and prisms use parallel line development. Now this is a truncated cylinder, so it's going to be made just a little bit different. And this is what it would look like. This is the isometric view. Here is the incline view of it, and here's the top view. Well, we know that this is an ellipse. So if we were going to put a top on it, we would actually make this ellipse over here. But how do we get this curve? How do we roll that out? And what we do is we divide our circle into 12. You could use the divide command and put points all the way around the circumference of that circle. And then you would plot those points straight down. So here's point 1, and we project that over, and then keep going 2 to 3 to 4 to 5. And actually, I would only do one side, and then I would have these points over here, and I would use a polyline to connect from point to point or intersection to intersection, and then use fit, or you could use a spline and actually create that. And then if we were in AutoCAD, we would just mirror the other side. If you're drawing it, of course, you're going to have to draw the other side. So this is a truncated cylinder, but that still is parallel line development. See all the parallel lines, okay? All right, and you can take your time and read through this because this is pretty good, okay? This is just a different way of doing the truncated cylinder. I don't know, you can look at it if you want, okay? And then, of course, now we're going to look into radial line developments, and what we usually use radial line developments for are things that will come to a point or an apex, okay? And it could be like a pyramid would come to a point, or a cone would come to a point. And so here is a radial line development of a cone. Here is a radial line development of a truncated cone, and these are fun to do too, and I wish we had time to do those. And then there are pyramids too. Now, so here's a pyramid, and here's where our true length diagram will come in, and you could actually make a drawing of this. They actually didn't draw this out. Oh yeah, they did down here. So this is how they did this pyramid. You had to get the true length line. In AutoCAD, it would be so much easier, but this is the radius of that true length line, and you're going to mark from here. In AutoCAD, I would draw a big circle, and then I would mark off all of these dimensions in it. I just wish I had the time to do it, but maybe next year. Okay, and this is also a radial line development. Even if the pyramid is oblique, it's still going to a point, and this would be the way this would look like. Okay, so those are radial line developments, and the radial line developments will use pyramids or cones, and they could be truncated or oblique. Okay, and then the next thing is triangulation, and this is something I really don't get into too much, but it's using a series of triangles, and it's a lot like radial line development, but just when one apex doesn't work, we'll just skip over that for now. But it is easier. It's very easy to do developments on CAD, and if we were in the classroom, that's exactly what we would be doing. There's some really neat tips in AutoCAD that you can do to do that. And actually this is in your book too, but we never really ever get to that. This would be a pretty cool PDF to save for future references. I'm going to go back to one other, oops, I hope this is it. Yeah, I'm going to another one I found, and I'm also going to put this in there because this just gives you some clearer pictures, I think. And I should give credit to whoever did this, frankmanella.com. Thank you very much for giving me something to work off of tonight. It talks about sheet metal and how there's different pattern or different joints in sheet metal. And if anybody goes on to anything, somewhere where you are bending sheet metal, you'll learn on the job, believe me. So these are the different types of it. And if you're looking around at file cabinets and things like that, things made out of metal that are bent, you might even want to look at this. Even I've seen some of this in cardboard too. So but we're not real worried about that right now. Actually, you might even go to classes if you're going on to like Northern. You might be looking at bend radiuses and stuff like that. We'll talk about that in a minute, but this is a parallel line development, and it looks pretty familiar. Here you can see it unfolding. Here is the fold development. We always mark the fold lines because people have to know where the fold lines are. Next year, if things go well, you'll be doing some of this in your design classes. Okay, and then when you're bending metal and there, you know, what happens is one side will compress and one side will stretch. So you actually have to you have to calculate the bend radius, and there are formulas that you do that with, and that's something that you'd learn in a more advanced manufacturing class. These are kind of things that you could see. This is a parallel line development. This is how it would be unfolded. This is parallel line cylinder, and that's how it would be unfolded. This is radial line development, and that's a cone, and this is a pyramid. So this is a prism, cylinder, cone, pyramid. And this is triangulation. And this is, like I said, that little bit more complicated way of doing radial line development. You could actually make this shape either way, triangulation or radial line. And this one is pretty complicated. I've actually seen somebody in high school do that, but I've never done it. Okay, so here's some typical sheet metal developments. You see that there's extra material left for depending on what type of seam is going to be there. I kept saying when I recorded your homework assignment, look for one seam, but there's more than one seam. So I don't know, but like I said, this is late and I'm saying a lot of things I don't really want to say. But this would look like a development drawing. You know, it says bend up 90 degrees. Usually these lines are like phantom lines or something like this, bend down 180 degrees, and you're going to solder. So there's a whole, you know, we could put a whole class together just on sheet metal drawings. So, okay, but here is a truncated, and it's a truncated prism. It says it's a letterbox. We have done these in class. Here's a truncated cylinder. Here's a little animation real quick of how they're doing this cylinder. And it's kind of cool, so I'll let you watch it. I don't want to have too many videos that take you too long. I am going to leave the survey up till the end of the semester because I know you are all probably scrambling to get done in all your classes. I want you to do as well as you can. We are all very aware, all of us teachers are very well, that this is very hard adjustment. We're all being pretty lenient, I think. And I know it's just as hard as on you as it is on me, although I don't know if any of you have stayed up. I mean, most Tuesday and Thursday nights I've stayed up till 4:30 or 5. So, okay, now these are also cylinder and parallel line developments. Even though that there's an angle, there still is a parallel line develop. These are still parallel line developments. Now this is radial line development. I'll let you watch this little video real quick. Hello. Just want to make sure I was recording. And there's the development, the flat development. Okay. All right. And now this is radial line development 2. Oh, actually, this is triangulation. It's pretty close to radial line development, only just doing it a little bit different way. They're pretty close. So I usually don't worry about that. This is a truncated pyramid because truncated just means that we sliced it. So this is how that would look. These are transition pieces, and I'm sure you've seen these, especially if you go down your basement like I did. Probably in your ductwork, you'll find some pieces like this. So going from square to round, hexagon to square, rectangle to round, square to oval, those are called transition pieces. And this is, we just learned true length diagrams. So remember, when you see a cone, actually a cone would be true length, but some things are like a pyramid would not be true length diagram or true length. So you'd have to make a true length diagram. This is a real quick video of a transition piece. I'll let it play, although I never usually assign a transition piece. Not so much because you couldn't do it, it's just because we usually run out of time in this class. We could do, like I said, we could do a whole probably semester on development drawings and sheet metal drawings and things like that. And I am sure if some of you are going to go on to Northern, you will be doing things like this too. So, and you're going to see it's going to go from square to round. And actually, not square. Yeah, it's square to round, but you see these triangles in here. Okay, here is a triangulation or transition piece. And here's a truncated transition piece, and that's the end of it. So I have got a kind of a really exciting assignment for you, and you'll see that in the assignments or in the announcements actually. So I think right now I'll be talking to you again in a couple more videos.